Here's problem 1517. At sea level, at a latitude where g is equal to 9.80 meters per second squared, a pendulum that takes 2 seconds for a complete swing back and forth has a length of 0.993 meters. What's the value of g in meters per second squared at a location where the length of such a pendulum is 0.970 meters? Alright, for a pendulum, we know we always like to start our angular frequency, and a pendulum we know it's square root of g over L. So the period in general is 2 pi over the angular frequency. That's going to be 2 pi times the square root of L over g. So this relates the period of oscillation for a pendulum basically to the square root of its length. I want to solve this for g because we're going to be trying to calculate g. And so let's square both sides. And then solve for g. I'm going to bring g over to the left and bring the t squared over to the right. So I have g is equal to 4 pi squared L over t squared. Now we're told, just for a check, that when the pendulum has a length of 0.993, we are measuring 9.80 meters per second squared. Let's check that out. G should be equal to 4 pi squared, and we're going to try 0.993 here. And our period of our pendulum is 2 seconds. Square that. So the 4 and the 2 squared cancel out. So I have pi squared times 0.993, and that is indeed 9.80 meters per second squared. So that assertion was correct. Nice to know. Okay, now we want to know what g is when the length is 0.970. So this new g, it's called g prime, will be equal to 4 pi squared times 0.970. And we still have the same kind of pendulum, so it still has a period of 2 seconds. So we have 2 seconds squared. The 4 and the 2 seconds squared will cancel out. And our new g will be pi squared times 0.970. That's 9.57 meters per second squared. So the value of g at our new location where a pendulum of 0.97 meters works is 9.57 meters per second squared.